Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on metallurgy. This will be our second lesson on this topic. In our last lesson, we defined metallurgy. We learned that it is the science and technology of extracting metals from their natural sources and preparing them for practical use. We learned the methods that are used to concentrate ore, including gravity separation, magnetic separation, froth flotation, amalgamation, and leaching. We also learned the purpose and process of pre-treating ore and the two methods used to extract metal from it. These include chemical and electrolytic reduction. In today's lesson, we are going to learn about two more major steps in the metallurgical process: refining and alloying. We will explain each of these and talk about some common examples. Students, if you are ready, let us begin. We discussed chemical and electrolytic reduction in our last lesson. I am sure you remember that these are methods of converting minerals into elements or taking the metal out of its ore. Metals that are prepared this way often need to be treated further in order to remove impurities. The amount of purification necessary depends on how the metal is going to be used. There are three common methods that are used for this purification process: distillation, electrolysis, and zone refining. Let us go through each method together. Metals that have low boiling points can be separated from other metals using a special type of distillation known as fractional distillation. This is the separation of a mixture into its component parts by heating them to a certain temperature. Metals such as mercury, magnesium, and zinc can be separated this way. Electrolysis is another important purification technique. Let us look at an example. When copper sulfide is roasted, copper metal is produced. This copper metal usually contains impurities such as zinc, iron, silver, and gold. Electrolysis can be used to remove the more electropositive metals. In this process, the impure copper acts as the anode and the pure copper acts as the cathode. I am sure you remember learning about this in our last unit. Zone refining can also be used to obtain pure metals. In this process, a metal rod containing a few impurities is drawn through an electrical heating coil that melts the metal in the metal rod. Most of the impurities dissolve in this molten metal. As the metal rod comes back out from the heating coil, it cools and the pure metal crystallizes. Impurities are left in the molten metal portion that is still in the heating coil. As the crystal reforms, the metal ions are likely to fit much better in the crystal lattice than are the atoms of impurities. This is how the purification of metal occurs. Performing this process several times produces a very pure metal. High purity is not always required or even desirable. Can you think of an example of a metal that is better off when it is impure? Discuss this with a classmate that is close to you.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. What metal did you think of? You might have thought of iron. Pure iron deteriorates by corrosion. Therefore, iron is more useful when it is alloyed or coated with other metals. If you thought of iron, great job. Let us move on with our lesson and discuss alloying. An alloy is a partial or complete solid solution of one or more elements in a metallic mixture or in nonmetal and metallic mixture. The primary metal is called the base. When there is a mixture of two types of atoms, it is called a binary alloy. When there are three types of atoms, it is called a ternary alloy, and so on. Alloys are produced by melting metals together to form a molten solution. The solution is then cooled to a solid state. Students, how does an alloy compare to its parent metals? Choose the most correct answer.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. You were correct to pick answer E. Alloys have the same general characteristics as their parent metals. However, they are stronger than their parent metals. This is because the atoms in alloys are of different sizes, whereas in pure metals, they're all the same size. The larger atoms in alloys exert a compressive force on smaller atoms, and the smaller atoms exert a tensile force on the larger atoms. This helps the alloy to resist deformation. Alloys are often used in jewelry making because they add strength and variety of color to metal. Alloying can also be used to create less expensive jewelry by diluting a more expensive metal with a less expensive metal. White gold, for example, is produced by adding metals like palladium and nickel to yellow gold. When silver and copper are alloyed, they create an appealing color of yellow. Many jewelers have their own recipes for creating different color and fineness in an alloy. Once the metals are melted together into an alloy, as we discussed before, they are poured into a brick mold and allowed to cool. These alloy bricks can eventually be used to create jewelry. In today's lesson, we learned about refining and alloying. We learned that metals are refined to remove additional impurities. We also learned that metals are alloyed to add strength, to offer protection against corrosion, and to create financial and aesthetic appeal. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.